Alright guys, welcome to the notes on 9-2. In these notes we're going to look at arithmetic sequences. Okay, we're going to be able to identify, define, and apply arithmetic sequences. So let's take a look at what we're talking about here. In an arithmetic sequence, the difference between any two consecutive terms is always the same number. We can build a sequence by adding the same number to each term. With a sequence, the common difference is a big deal, so that's this difference between each number that we're talking about. Um, a recursive definition for this sequence has two parts. So A1 equals A, that's the initial condition, and then A sub n equals A sub n minus 1 plus D being the difference, is the recursive formula. This we learned and use in Algebra 1. An explicit definition for this sequence is a single formula. Okay, it's a single formula for a specific number, and that's if we're just trying to find one. Okay, so let's take a look at what this looks like in a problem here. So, for example, is the sequence an arithmetic sequence? Find the differences between the consecutive terms. If the difference every time is the same, then it has a common difference. So the answer is yes, it's arithmetic. If we look here, the difference each time, even though there is a pattern, the difference each time is not the same, so it's not an arithmetic sequence. No common difference. Okay, simple as that. This is patterns that we should be pretty good at just identifying. So take a second, pause the video right here. Tell me, is this an arithmetic sequence or not? All right, you're back. Hopefully you got these right away. 1A is a no because the difference is not the same each time. 1B is a yes for the exact same reason. All right, let's take a look at problem 2. So analyzing sequences. So what's the 100th term? Well, we don't want to go through and figure out, like, counting each term. If we start with 6 and then 11 and it's an arithmetic sequence, we know the pattern is 5. But I don't want to calculate each term. So we use the explicit formula. We want to know a to the 100th term. We know that a is the initial value here, so we started at 6. We do n minus 1, so that's 100. We're looking for the 100th term. Minus 1 times the common difference, and we get 501. Here, what are the second and third terms of the arithmetic sequence? 100, blank, blank, and then an 82. So the first term is 100, the fourth term is 82. There are three common differences between 100 and 82, so we have to figure those out. So first you have to figure out what's the common difference. So 100, and then we figure out that the difference here is 18. So if we divide that by 3, this is 100, and then this would be 94, this would be 88, and that would be 82. So you have to figure out what that is. Once we have that, the second and third terms are 94 and 88, so that was our answer. That's just finding the missing piece. Okay? Go ahead and take a second. Try 2A and B. Go ahead and pause the video here and try that. All right, you're back. Hopefully for 2A, you got 93. Just by plugging it into the formula, and hopefully for 2B, you were able to figure out that the missing terms were 95 and 110. Okay, so far, so bueno. The arithmetic mean or average of two numbers, we know that. You just add them up and divide by 2. So in an arithmetic sequence, the middle term of any 3 consecutive terms is the arithmetic mean of the other 2 terms. So what that means is, if I have 3 terms, then the middle number is literally the middle number. It's the average of them. So right here, we have 15 and then blank and then 59. So what is this? Well, if we just add 15, 59, divide by 2, we get 37, and that's the missing number. It's really that easy. The 9th and 11th terms here are, go ahead and just try 3A and 3B. Try those. All right, you're back. 3A, that was 115. 3B asked, if you know the 5th and 6th terms of arithmetic sequence, how can you find the 7th using arithmetic mean? Well, very simply, if we know the 5th and 6th terms, the difference between 5 and 6 is going to be the same difference from 6 to 7. So it's really just about finding the common difference. Okay. Use an explicit formula for arithmetic sequence. So we have the sports arena. There's 13 seats in a row of an arena that form a sequence. Rows 1 and 2 are shown in the diagram. How many seats are in row 13? So here there's 14, then 16, and we're telling you it's a sequence. The common difference is 2, so you just plug it into the formula and you get 38. It's really no problem. Go ahead and pause the video here and try and find how many seats are in row 16, and got it, number 4. All right, you're back. Hopefully for that one, you got 65 seats. That's it, guys. Those are the notes for 9-2. You're going to need 9-4 also. That's coming up in a separate video. Make sure you watch this one and that one. Bye. All right, welcome to the notes on 9-4, where we're going to talk about arithmetic series. This is similar to sequences. It's just a sort of a step further. As we found formulas for terms of sequences, we can find formulas for the sums of the terms of sequences. So, couple things. A series is the indicated sum of the terms of a sequence. So if a series is finite, that means it has a beginning and an end. It has a first and last term. When that happens, we can find the sum of that sequence. Okay, so a finite series, we can find the sum of it, while an infinite series goes forever. So a finite sequence would be 6, 9, 12, 15, 18. We can find the sum. Their sum is 60. That's no problem. An infinite sequence is one that just goes forever. So there is no sum of something that goes forever. An arithmetic series is a series whose terms form an arithmetic sequence. When a series has a finite number of terms, you can use a formula involving first and last term to evaluate the sum, and this is that formula. Okay? So let's take a look at how this plays out in the problem. So what is the sum of the even integers from 2 to 100? Really simple. Sum of even integers from 2 to 100. So we use the formula. There are 50 terms between the first and last. Their common difference is 2. We started at 2 and went to 100. We plug all that into the formula, and we're home free. Okay, it's really as simple as it gets. Okay, so we're plugging this in. If you didn't write it down, we're plugging this in to this formula down here. Okay, the sum equals n over 2. N is however many terms there are. And then it's a1 plus a to the n. So again, the first term to the last term. Okay, so that's what we did here. So 50 over 2 times 2 plus 100 equals this number. So what is the sum of the finite arithmetic series here? Go ahead and figure that out. 1a and then 1b, please. Go ahead and pause the video here and do that now. All right, you're back. The sum here for 1a is 1,030. Goodness gracious, that's a 3. And then question B wanted to know, will the sum of a sequence of even numbers always be an even number, and will the sum of a sequence of odd numbers always be an odd number? And the answer to that is yes and then no. So when we add even numbers, yes, we're always going to have an even number. The odd numbers is no, because the sum of an even number of odd numbers is even. Think about it. If 5 plus 7, those are both odd, but they add to 12. 5 plus 7 plus 9 plus 11, that's 12 plus 20, that's 32. So if it's an even number of odd numbers, then it's going to be even. So that's a yes and then a no. And we talked about why. If you have questions on that, make sure you bring it up in class. So using the sum of a finite arithmetic sequence, so here's how this can be used. So a company pays $10,000 bonus to salespeople at the end of their first 50 weeks if they make $10 in sales their first week and then improve their sales numbers by 2 each week thereafter. One salesperson qualified for the bonus with the minimum possible number of sales. How many sales did that salesperson get in week 50, and then how many in all 50 weeks? So right here we have the first week of sales were 10, and it's got to go up 2 each week. All right, the sequence is arithmetic, so we use the explicit formula to find the sales in week 50. So we plug everything in. That's all we're doing. We just plug everything in and find that we have 108 sales in the 50th week. Okay, this is into the explicit formula. Into the explicit formula. Then we use the formula for sum to find the total sales in all 50 weeks. So we plug in these numbers and we get 2950. Okay, it's really that simple. Got it 2 is very similar. Pause the video right here and see if you can get got it 2. Okay, so just like in got it 1, there were 2 questions. How many sales did the salesperson make in week 50 and then in all 50 weeks? In week 50, it was 59 sales. In all 50 weeks, it was 1,700. Goodness. It was 1,725 sales. And if you didn't get that, try again. If you still don't get it, make sure you pause the video or make a note of it, and we'll get it in class. So we use the Greek capital letter sigma to indicate sum in all math. So with it, we can use limits to indicate how many terms you are adding. Limits are the least and greatest values of n in the series. Okay, so we write the limits below and above the sigma to indicate the first and last terms. So upper limit here is 108, and the lower limit is 3. So this is the sum of all the terms from 3 to 100. Okay. The explicit formula for each term is n squared. For an infinite series, summation notation shows an infinity sign as the upper limit. So if it's never going to end, then the upper limit is infinity. That should make sense. To find the number of terms in a series written in sigma form, subtract the lower limit from the upper limit and add 1. So in this one, we subtract 108 minus 3 plus 1, and that's 106. All right? So first of all, let's just practice writing these terms out, and then what's the summation? So if we take a look at this one, what is the summation notation for this series? So we have 7 to 207, and then inside here we have to put what's the pattern for, what how we're growing. So the sequence 7, 11, 15, all the way up to the A equals 7, all right, and the common difference is 4. So we use this, the explicit formula, to find what the sequence is. So that's how it comes. These are all 4n plus 3, 4n plus 3. So I know those are right. So this is wrong, and this is wrong, okay? Because 4n plus 3 is what has to go in. Then the explicit formula for the nth term is 4n plus 3. Well, the nth term is 207, and that equals 4n plus 3. So we substitute this in and solve, and we get 51. Okay, all we're saying is that the last term, that's 207, so that must have been the 51st term. So the upper limit is 51, the lower limit is n equals 1, and then the explicit formula to find it was 4n plus 3, so the answer here is A. Don't worry about memorizing these formulas. You have them in your notes now. I'm going to give you the formulas on the formula sheet. Go ahead and take a second, see if you can come up with summation notation for each of these series, 3A and 3B. Pause the video here and come up with those. All right, you're back. Whoa, 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 whoa. You're back. Let's take a look. So A is we have sigma, we have 40, we have n equals 1, and in parentheses we have negative 12 plus 7n. Okay, so that's A. Let's see if I can draw a better sigma on B. So B, we have the sigma, and it's 50 is the upper limit. 50, n equals 1 underneath, and the explicit formula there is 510 minus 10n. Okay, if you didn't get those, that can be complicated. We'll go over those in class. If the explicit formula for the nth term in summation notation is a linear function of n, then the series is arithmetic. Okay, so if this part right here, the explicit formula, if this is linear, then it's arithmetic. The slope of the linear function is the common difference between the terms of the series. The slope, so this part attached to the end, that's the common difference. Okay? What is the sum of the series written in summation notation? So here we actually find the sum. So we just plug the numbers in that are given. We plug the 70 in for n. We find 353. Then we use that to find in summation right here, use the formula for the sum of an arithmetic series. Because what we have to do is, if we have this information, we have to find the first term, we have to find the 70th term. Once we have those, we can plug those into the summation formula. No problem. Here, this series is not arithmetic. However, we can evaluate it by adding the terms, okay? So what happens is we have from 1 to 7, so we add them all up and we get 91, even though it's squared, okay? So go ahead and evaluate what's the sum of each of these series, for A, B, and C. Go ahead and pause the video right here and find the sum of each finite series. Go ahead and do that now. All right, you've unpaused. Hopefully, here you got 2140. Hopefully here you got 100, and hopefully here you got 1. All right. How to use a graphing calculator to find the sum. This is a little bit difficult. So the steps are on here. This is only for TIs. We're going to do this together in class. Okay, so don't worry about that right now. We'll do this together in class. That's it for the notes, guys. See you next time. Bye.